In this video, we'll be continuing to talk about the margin of error. We'll go through the steps that are followed to calculate the margin of error, then we'll look at the formulas that we'll be using to calculate the margin of error, and then we'll go through some step-by-step examples together. In all of the examples that we'll be going through in our class, the margin of error is calculated with 3 steps. First, you select a confidence level, which just means you select a percentage. You decide if you want to calculate the 70% margin of error, the 80% margin of error, or a margin of error with some other percentage. Next, you look up the confidence coefficient for your selected confidence level. You look it up in a table, and I'll be sharing that table with you. Once you have your confidence coefficient from the table, you plug it into the margin of error formula, and you get the margin of error. More specifically, you multiply the confidence coefficient by the standard error, and you get the margin of error. And we already know how to calculate the standard error. We learned how to calculate it in earlier videos. So if you already know how to calculate the standard error, then the margin of error is just one step further. And this formula that I'm showing you right here is a generic formula that applies to all of the situations that we'll be going through. But there's actually 2 separate formulas that we'll be using to calculate the margin of error. So we'll be calculating margin of error for sample mean and margin of error for sample proportion. Both of these formulas are a confidence coefficient written as a z-score times a standard error. The difference between these 2 formulas is that one formula has the standard error for a mean, and the other formula has a standard error for proportion. So the 2 formulas are the same except for the fact that they have different standard errors. And we already know how to calculate these 2 standard errors, so the margin of error is really just one step further ahead than the standard error. Before you can calculate a margin of error for a mean or for a proportion, you have to know that the sampling distribution is normal or at least close to normal. And in each problem that we'll be solving, we'll be going through a checklist to determine whether the sampling distribution is normal or at least close to normal. If the checklist checks off, we'll go ahead and solve the problem. If it doesn't check off, we'll just say that the problem can't be solved. So when a sample mean is being calculated, the sampling distribution is at least close to normal if the population is normal or the sample size is at least 30. We learned a few videos back that when a sample mean is being calculated, the sampling distribution is perfectly normal if the population is normal, and the sampling distribution is roughly normal if the population is skewed and the sample is 30 plus. So if we meet this or this, one or the other, then the sampling distribution is at least close enough to normal. And this is a new checklist we haven't seen before. When a sample proportion is being calculated, then the sampling distribution is close to normal, not perfectly normal, but close to normal if this is met and this is also met. And we'll learn how to go through this checklist once we get to an actual problem. So we have 2 different formulas and 2 different checklists. We have a formula and a checklist for one situation, and a formula and a checklist for the other situation. So we have all we need to go ahead and get to an example. So here's our first example of calculating the margin of error. In this situation, a population has a mean age of 20, the standard deviation of the population is 4.2, and we know that the ages in the population have a normal distribution, or a bell shape, and we're imagining that a certain person randomly selects 17 people from this population, records their ages, and calculates the mean age of the 17 people by adding and dividing by 17. And before we can go anywhere, we have to decide if the sampling distribution is at least roughly normal. And this is the checklist we have to use in this situation. In this situation, a sample mean is being calculated, which means that we have to use the checklist for a mean, not the one for a proportion. So the sample size is not 30 plus, but the problem says that the population is normal, and that checks off. So since one of these checked off, the checklist is met. The reason why I said or right here is because this or this has to be true. all we need is just for one of them to be true. And if they're both true, that's fine, but they don't have to both be true, just one or the other. So we can go ahead, since we've met our checklist, and now in part B, let's calculate the 70% margin of error. Well, first we have to go to a table and look up the confidence coefficient for 70%. And I haven't given you a table yet, but when you go to the table, it'll tell you 1.04. And we have to also calculate our standard error. And the standard error for a mean is the population standard deviation divided by the square root of the sample size. And the problem is telling us that the standard deviation is 4.2. That's this right here. And the sample size is 17, which is this right here. So let's plug both of these in. And let's go ahead and solve it. So first let's find the square root of 17. It's about 4.12. Let's divide 4.2 by 4.12, and that comes out to 1.02. And let's multiply the confidence coefficient by the standard error, and we get 1.06. That's the 70% margin of error. One thing I wanted to mention before we move on is that you might remember that in some situations we had to include an extra piece to the formula. If the population, I'm sorry, if the sample is more than 5% of the population, then you have to include an extra piece right here. It's a correction. But in all of the margin of error problems we'll be doing, the sample is always 5% of the population or less. It's never more than 5% of the population, so that this extra piece will never be needed in our margin of error problems. So now in part C, let's interpret the margin of error and decide what it's telling us. Well, I told you in the last video that the margin of error is it's an amount of accuracy that has a certain probability of being reached. And I think I told you in the last video that if the 70% margin of error was 2, then that would mean that the sample mean has a 0.70 probability of falling somewhere between 2 below and 2 above the population mean. So if the 70% margin of error is 1.06, that's telling us that in this situation, there is a 0.70 probability that the sample mean will fall somewhere between 1.06 below and 1.06 above the population mean, which happens to be 20 in this situation. And now let's make a diagram just to show, just to visually show what I just said. So the population mean is 20 in this situation, and we know that the population mean has a z-score of 0 always. And here we have 1.06 below the population mean and 1.06 above the population mean. And 1.06 is our 70% margin of error. So this is the 70% margin of error, and this is also the 70% margin of error. So the 70% margin of error is just the distance from this population mean to the lower end and to the upper end of the middle 70% of our sampling distribution. It's like the radius of the middle 70%. And right here, we have 1.06 below and 1.06 above. And since this is the middle 70%, there is a 0.70 probability that the sample mean will fall somewhere between these two boundary points. And I got this number right here, this 18.94, by just taking 20 and subtracting 1.06. So this is just 1.06 below 20. And I got this number by taking 20 and adding 1.06. So a really simple way of saying our conclusion here would be just to say that there's a 0.70 probability that the sample mean will come out between 18.94 and 21.06. That's really all we're concluding right here. And this z-score 1.04, that's our confidence coefficient. It's just the z-score we plugged in to get the 70% margin of error, which came out to 1.06. and the 1.04 came from a table. And anytime you have a normal distribution, 70% of the curve is between 1.04 and negative 1.04. That's always the case. And let's move on to one more example. So once again, we have a population mean, we have a population standard deviation, but the population members have a certain shape. But now the population members have a skewed distribution. It's not a normal distribution. It's piled up toward one end. And in this situation, a person is randomly selecting 45 people, giving them a survey, recording their ages, and calculating the mean age of the 45 people. And first, in part A, we have our checklist. In this situation, the population isn't normal, but the sample is 30 plus. So this checks off, and the answer to part A is yes. And since we met our checklist, we can go ahead and solve the problem. Once again, we go to the table and get our confidence coefficient. This time we need the coefficient for 95%, which happens to be 1.96. Then we plug in the two numbers to get our standard error. They're provided in the question. And the square root of 45 is 6.71. We divide, and the standard error is 0.63. Then we multiply, and we get 1.23. That's the 95% margin of error. And now let's reach our conclusion. Since we calculated the 95% margin of error, the probability is 0.95. So there is a 0.95 probability that the sample mean is going to fall somewhere between 1.23 below and 1.23 above the population mean. And another way to say that would be just to say that there's a 0.95 probability that the sample mean will fall within 1.23. When I say within 1.23, I just mean somewhere between 1.23 below and 1.23 above. Now let's turn our conclusion into a diagram. So we have our middle 95% of the sampling distribution. There's a 0.95 probability that the sample will come out somewhere in this area between these two boundary points. This boundary is 1.23 below the population mean. This boundary is 1.23 above the population mean. So the 95% margin of error came out to 1.23, and that's the distance from the center, the population mean, out to here and out to here. That's why I labeled the bars 1.23 and 1.23. I got this number by subtracting 1.23. So 20 minus 1.23 is that number. 20 plus 1.23 is that number. And there's a 0.95 probability the sample mean will come out between here and here. Now let's go through one example of calculating a margin of error for a proportion. So now a certain population is 47% male. A person selects 58 people from the population, records their genders, and calculates the proportion of males in the sample. In this imaginary situation, the person is going to count the number of males in the sample and divide that by 58 to get a proportion. So let's say that 20 out of 58 people are male. Well, you would just divide 20 by 58, and that would be the proportion. Or let's imagine that 28 out of well, no, not 28. Let's say 29 out of 58 turn out to be male. Well, 29 divided by 58 would be 0.5. That's half male, and the sample proportion would be 0.5. But we're not going to be calculating the proportion of males in this example. We're just imagining that this person is going to be doing that with his or her data set. And all we want is the margin of error. We want to calculate the margin of error to reach a conclusion about what this person's proportion will come out to. So we have our checklist right here. First we need n times p. So n is a sample size, which is 58 people. P is the proportion that's provided, which here is 0.47. We have to write it as a decimal. So n times P is this, and n times 1 minus P would be 58 times 1 minus our proportion. 1 minus 0.47 is 0.53. When we multiply here, we get 30.74. What the checklist is saying is that both of these numbers have to be 10 or larger. This has to be 10 or more, and this has to be 10 or more. And they both are 10 or more. They both check off, which means that we can move ahead. The answer to part A is yes. But remember, when you're dealing with this checklist, they have to both check off, not just one or the other. That's why it's and not or for this checklist. Now let's move ahead. So what we do now is we look up our confidence coefficient in a table for 95%. It's 1.96. We calculate the standard error the same way we did in an earlier video. We take our proportion of 0.47, we plug it in for P. We take our sample size of 58 and plug it in for N, and we just solve for the standard error, and we multiply by 1.96, and we get our answer. So in this situation, the 95% margin of error is 0.13. And in part C, let's reach a conclusion. So we have a 95% margin of error, which means that there's a 0.95 probability that this person's sample proportion, which this person is going to calculate, will come out somewhere between 0.13 below and 0.13 above the population proportion. Notice how the conclusion is written the same way as it was before, except every time we used to say mean, we're now saying proportion. So this used to be mean, this used to be mean, but now we're saying proportion because now a proportion is being calculated. So there's a 0.95 probability that the sample proportion that's being calculated will come out somewhere between 0.13 below and 0.13 above the population proportion. That's another way of saying this, what I'm saying right here. And let's show it as a diagram. So here we have the middle 95% of possible samples in our sampling distribution that we'll mark off. There's a 0.95 probability that the sample will come out in this middle area, in the middle 95%, between the boundaries. This is 0.13 below, this is 0.13 above, and this is the population proportion at the center. So this is the population proportion. This distance going out this way is 0.13 to this boundary. This distance going out this way to this boundary is 0.13. And there is a 0.95 probability that the sample will come out somewhere between 0.13 below and 0.13 above, and land between the two boundaries. And once again, down here, I labeled the margin of error. All I'm saying right here is that this distance going out this way is 0.13, and this distance going out this way is 0.13. And remember that the center point right here is our population proportion, 0.47, and that was provided in the question. We know that it's 0.47 male. So now we've gone through two examples of margin of error for a mean and one example for a margin of error of a proportion.